Okay, so anybody willing to share marks? Like just, what are you at? What's your mark at in Essential right now?
I don't know, I'm just,
Well, you should know it. Okay, let's say 95. Okay, well, we're just talking about Essential.
Oh.
So tests, assignment, you don't correct this now. Tests, assignments, you've got a 95% complete. There is also the provincial exam. Okay, which we don't have a mark yet. So let's say, I don't know, 85 on the provincial exam. If I didn't give you any more information, what would your mark for the course be? Average these two and you get 90? Okay, because I didn't give you any more information, right? However, that's not the case. The tests and assignments you guys do during the year is worth 70% of your grade. Sorry, 80%. The provincial exam is only worth 20%. So because this is worth more or it weighs more, we can't just say that your final mark will be the average of these two. It'll actually be higher than the average of these two because this has more weight in the course, which means your higher mark has more weight. So this is another type of calculation we're going to do, is called the weighted mean. So how you do it is you would take how much the tests are worth times your mark. Then you would add how much the exam is worth times your mark divided by the weight of the test assignments and the exam. Don't worry, I'll write this down later. So if we were to do this, we would get 80 times 95, and we add that to what? 1700. And we divide that by 100. And it turns out your mark for the course would be 93%. Okay? Which makes sense because the part that you scored higher on is worth more in the course. So your mark should be higher than just the average of that. This is something called weighted mean. We don't just add up the numbers and divide by how many there are. We have to multiply by how much they're worth. Okay? And then we have to divide the total worth. So you can see this. So you guys can play the little mark game if you want. You can say, oh, okay, I'm going into the exam with an 87. What do I need on the provincial so that I don't get lower than 85? Well, you would do these type of calculations to figure it out. Okay? Because often that's, and especially in pre-calc, that's a question I often get. Is what do I need on the, like if I go into the exam with this, and if I just pass the exam, what's my mark? I get that question all the time. Okay, so basically, I'm not going to talk about this whole first section here because I've talked about the weighted mean. But here's an interesting question, though. Let's say you have a choice between two science classes. in one science class, the final exams were 75%. Assignments are worth 5%, and there's only one test worth 20%, for a total of 100% of your coursework. In the second science class, the final exam is only worth 33.4. The assignments, we don't know how many there are worth 33.3, and 3 tests are worth 33.3. Which course would you rather take?
I'd rather take the second.
The second one? Why?
I'll read over my.
No. So honestly, this is an opinion question. There's no right, wrong answer.
Because personally, I feel like if I fail an exam, then I'm getting 90. Honestly,
Yeah, like if you don't do well on exams, yeah, you probably don't want to take this one worth 75%. Because this way, at least you're building up some marks in the second course. Okay? Definitely. But maybe some people work well on the final exam and they would prefer fewer assessments. So they would take this course instead. I took a course in business once, the exam was 100%. No tests, no quizzes, no assignments, just at the end of the course, exam 100%. That was stressful.
I feel like I could do that one, but not this one, because in that one, like, I'm working up to an exam. With this one, like, I would get too comfortable, like, leaning on my assignments and then do work on my.
For this one?
Yeah,
I see.
because if I like know those, like, the final ones with a lot, I would
Yeah.
be more focused on that instead of leaning on my work.
Yeah. No, that's a good point. Okay, so how do we calculate these things? And we use weighted means in a lot of different situations. One, marks being one, because courses are always weighted. Okay, you get a certain weight for tests and quizzes and assignments and projects and exams. Sometimes you'll even get marks for participation. But the general formula to find the weighted mean is this. This is not on your formula sheet. So this, for your reference sheet for the test in this unit and for the provincial exam, you definitely want this formula to write it on your reference sheet. Okay? And it looks like this, and I'll explain what the symbols mean. Okay?
Is that something that are formula sheet?
Finish saying no.
Oh, I didn't start it. I was like, it was okay.
No, this is, you want to write this on your reference sheet.
Okay.
Definitely. This symbol means you add up numbers. So you may have to do a few of these, X times W's, because there may be more than one. This means just once you do them all, add them all up. So this means find the sum. X is the individual data value. Or if we were talking about like a course, an academic course, it would be your mark. That would be the data value is your mark. And W is the weight of each item. Okay. So basically what you're going to do is you're going to get a list of different weights and you're going to get a data value for each weight. You multiply each of those together and you add them all up. And then you divide by the total weight, which is often 100, because it would be like 100%. Okay. And notice the steps are there too. So let's just look at a couple of examples. So this is not really a new type of statistic. It's just a different type of way to calculate mean. So let's stick to something that we're familiar with right now before we branch off into other things. So you want to figure out your final mark on a course. Assignments are worth 75%. We got a midterm exam worth 12.5, final is worth 12.5. And then it tells you the marks that you've received. So what are the items here? There's three of them. There's assignments. There's the midterm. And there's the final. And then so I'm going to skip the second column for now because I'm told the weights of each one. So you don't have to change these to decimal. You could, it would still work. But I can leave it as just 75 for the assignments, 12.5 for the midterm, 12.5 for the final. So now, what are the marks that we got in each category? Well, we got 76 on the assignments. 68 on the midterm. And you think you're going to get 80 on the exam. So you haven't written the exam yet. So to figure out your final mark or your weighted mean, you multiply all these pairs together and add them up. So it's going to be 76 times 75 plus 68 times 12.5 plus 80 times 12.5. And then you divide that by all the weights together. So you add up all the weights, 75 plus 12.5 plus 12.5. That's how you calculate these things all the time. The data value times the weight, add those all up on top, add up all the weights for the bottom, divide. And when you do that, I'll just give you guys the answer because surely you can be able to do it on your calculator. You get 75.5%. Which makes sense because, you know, your assignments, which is the majority of the course, you got 76. The midterm, which was lower, brought it down a little bit, but the final brought it back up a little bit. So you should be somewhere around 76, and we see that we are. Okay. Okay, this one, a little different. Teachers of 2 grade 12 English classes at Massey want to find the mean final exam score. Remember, mean means average. The first class has 24 students, and the mean was 62. The second class has 30 students, the mean was 78. Why can't I just add the 2 marks and divide by 2? Why can't I just add the 2 classes' marks and divide by 2?
They're not even.
Because they're not even. Exactly. Okay. If they were even, if they both had 24, I could do that. If they both had 30, I could do that. But as soon as they have different ones, I have to use that weighted mean formula. So the 2 items are, well, the first class and the second class. What was the average or the mean in the first class? Of the final? 62. And what was the mean of the second class? 78. Now, this time, the class sizes are the weights. So class 1 has a weight of 24, and class 2 has a bigger weight of 30 because there's more students. And then you just multiply, add, divide by these two added together, just like you did before. So to find the answer, we would go 62 times 24 plus 78 times 30. And then on the bottom is the weights, the sum of the weights. And if you do that, you're going to get about 70.89%. Which is close to the average of the two, so not quite the same. Okay. All right. So we can see a couple of places. One, in schools, that's one place that we can use it. Okay. But you can see here, here's where we use it. When we have an imbalance in something we're trying to find the average of. Like if we're trying to find the average of several groups, okay, but they're all weighted differently, that's when we use a weighted mean. That's essentially what all this is, okay? So let's look at another one. 50 students taking grade 12 essential, whereas how many hours they spent studying for an exam? 20 students said 6. 13 students said 4. 9 students said 2. 8 students said 9. What's the mean or average time that these students spent studying? Well, the items are 6 hour, 4 hour, 2 hour, and 0 hour. And what are the values of each one? Well, that's how many students. So 20 students said 6. 13 students said 4. 9 said 2. And 8 said none. What's the weight of each category? The number of hours. 6, 4, 2, 0. And then we multiply all these pairs together, add them up, and divide by the total weight. Okay? Wait a minute. Did I do that right? Yeah, I think I did that right, didn't I? How do I feel like I've done something wrong?
The 8 is it?
No, I think that's right. Okay, so, yeah, because we want to, like the total number of hours at the 6 hour group will be the product of these two. So, yeah. So 20 times 6 plus 13 times 4 plus 9 times 2 plus 8 times 0. And we divide it by the sum of the weights, 6, 4, 2, 0. Why do I feel like that's wrong? No, you know what? These are the weights thing. Yes, I'm sorry. These are the, we've got to switch all these. We've got to switch all these. That doesn't change the top. The top is still the same.
Man,
Okay? It's just the weight, yeah, because the weights are the number of students. My mistake. So 20
plus 13 plus 9 plus 8.
And that will give us 3.8 hours. Because yeah, the other way would have given us, that would have given us way too big a number. Where this makes more sense. Yeah, so your multiplication up top is all still the same and adding. It's just I got the weights and value columns incorrect. Okay. Okay, final example.
So yes, remember I always said that data can always be used in a bad way to present an argument that you want to present, and it may not be mathematically accurate. Well, weighted mean helps counter that. So here we have a chart of people from Manitoba and Quebec, which are really the two provinces where French is spoken. Okay.
Really?
Well, I mean, New Brunswick, there's also French spoken there and in other places too. But Manitoba and, well, definitely Quebec, right? And Manitoba has a decent sized French speaking population. Okay, so this is from 2006. So in Manitoba, 87.27% speak English, 1.72% speak French. That's their language spoken at home. Obviously, this doesn't add up to 100% because there's other languages that are spoken. It's just that they're usually a smaller percent. In Quebec, however, though, English is only spoken by 10% of the population, slightly above, whereas French is spoken by over 80% of the population. So one statistician claims 48.64% of people from Manitoba and Quebec speak the English language most at home. Note that 48.64 is the average of those two. Okay? Does that make sense? And you can kind of look at B for a little bit of a hint. It would make sense if the number of people in each province was the same, right? But Quebec is a much bigger province population-wise than Manitoba, okay? So we can't, this goes back to that first example I did at the beginning. We can't just add the two and average them because the weights are different. There's more weight in Quebec than there is, like population-wise, than there is in Manitoba. So we would say no, because populations aren't the same. So that's not a good way to do it. It's a good way to show bad data or show data badly. Okay. But mathematically, no. We need to know the populations. Okay. And when we know the populations, we can do the calculations. So remember, the people are the weights. These are like the marks, the data values. So we want English, we want to use these two. So for Manitoba, the percent that speak English is 7.27 times the population of Manitoba. And then we want to take the percentage that speak English in Quebec times the population of Quebec. And we want to add those two together. And then we want to divide the total weight or total people. So we have to add the two populations. Like so. So this is a data value times weight plus data value times weight over the sum of the weights. And when you do that, you get 20.2% speak English. At home. In Manitoba and Quebec. Okay, which makes much more sense. Because there just wouldn't be that many that would speak English in the percent of 48 is way too high, right? Because the population of Quebec is very high and the percentage of that speak English at home is low. So how might the media use statistics, such as the mean, which was A, instead of B, which was the weighted mean? If we want to say many people,
Did I say 14? Oh, if we want, okay.
if we want to say many people speak English at home in Manitoba and Quebec. Like if somehow we want to portray that a lot of people speak English at home in those two provinces, when in reality, it's not that big. Okay. To say, you know, oh, we don't need English speaking. We don't need as many English speaking programs because look at how it's almost 50% speak English in Manitoba and Quebec, when really it's only 20%. If you want to promote the English language. Okay.